All right. The first problems just want to know how to transform the graph of basically like whatever they're giving us, or like the graph of x raised to whatever the n power is, which would be whatever power they give you in the problem, to whatever we have. And it works the same way as all the other stuff that we've been doing, so we're only going to do a couple of them. But if I have, oh, no, number 4. G of x equals 2/3 times x minus 3 cubed plus 1. And I want to know what transformations are occurring. Like I said, they're the same as from the previous sections that we've done. So what's occurring to this one? Up 1.
Right 3.
Right 3.
Vertical compression of 2/3.
It's being compressed.
And then
That's it. 6. G of x equals 3 times x minus 1 raised to the 4th minus 2. Stretch. Right 1. Down 2. So those work the same way as the problems we'd been doing, so nothing any different about that. So we're going to kind of jump a lot, and we're going to look at in behavior. So in behavior, we do like a little bit more with it in this class than we did in Algebra 2, but we do a lot with it in calculus. You can ask Virginia. In behavior is basically what happens as x gets really big or really small. And so we would write it as essentially the limit as x approaches infinity of f of x, or the limit as x approaches negative infinity of f of x. So when I'm doing these problems, I think, okay, if I were to plug in 500 for whatever I have, then what's happening to this function? Okay, so big things to pay attention to are what is the power on the x. I only care about the highest powered x term. Essentially everything else I can just kind of like erase and pretend that it doesn't exist, because it's not going to be at such a large number, it's not going to matter what everything else is doing, only the highest powered term. I've got to pay attention to signs as well and make sure I know what's going on with that. But the other thing, back to what I mentioned in the notes, is that we talked about how if functions are odd, one's going like positive and one's going negative. If they're even, then both are going up or both are going down. So when you have an even or an odd function, you should be thinking about that when we're looking at these limits as x gets really, really big or really, really small. So 26, f of x equals negative x cubed plus 7x squared minus 4x plus 3. So something else to note about these problems is you need to make sure that they've written them in standard form. Sometimes they will try to trick you and write them in a different form to get you to pay attention to the first term. I don't care about the first term, I care about the highest powered term. So, that being said, what is my highest powered term in this one? Yep, negative x cubed. So all I care about is this negative x cubed. So it wants me to evaluate the limit at infinity and at negative infinity. So the limit as x approaches infinity of f of x, or if you want, you can write of negative x cubed, if you want to write it that way instead, because that's all I care about here. When I plug in a really, really big number for x, what is this going toward? Negative infinity. And that would be your answer. Because if I plug in 500 and I cube it, and then I put the negative on it, it would be negative infinity. And obviously 500 is a big number, but it's not nearly anything of what we would think of as infinity. If I did the same thing but for negative infinity, so the limit as x approaches negative infinity of negative x cubed, what would happen if I plug in a negative really big number? It would be going toward positive infinity because a negative number cubed is going to stay negative times the negative that was out front is going to make it positive. I also know this is an odd function. I need one going toward positive infinity, one going toward negative infinity, and so I know that that makes sense for my answer. (28) f of x equals x cubed minus x to the fourth plus 3x squared minus 2x plus 7. Is this one in standard form? No. So if I'm going to look at in behavior, what term do I need to look at? Negative x to the fourth. So now I do the same thing. It's an even function, so what should be happening with my final answer?
Both are the same.
They both should be the same. Now, I would recommend you not just write them down as both the same as soon as you do the first one. I would make sure you check in case you happen to do something wrong, but obviously they should be the same when you're all said and done. So the limit as x approaches infinity of negative x to the fourth, if I plug in a really big number, positive number, what am I going to get out? Negative infinity, because the positive being raised to the fourth is going to be positive, but times the negative is negative infinity. Then the limit as x approaches negative infinity of negative x to the fourth. If I plug in a really big negative number, what's going to happen? So a negative number raised to an even power is going to become what? Positive, but there's a negative in front, so what's going to happen? Negative. So negative infinity. And those are both the same, so I'm good to go. All right, unfortunately, that's all that they give us on in behavior, like in terms of problems. Are there any questions about those? I know we did a little bit with them last year, but like not a ton. Find the zeros of the function algebraically. So that could be factoring in different methods. It could be taking something out. Basically all just different varieties of that. So number 34. F of x equals 3x squared plus 4x minus 4. So arch method, I need factors of negative 12 that add up to give me positive 4. Any ideas? Positive 6 and negative 2. So 3x squared plus 6x minus 2x minus 4. Factor by grouping. Take out a 3x, I'm left with x plus 2. Take out a negative 2, I'm left with x plus 2. So my factors then are 3x minus 2 and x plus 2. Now, I'm trying to find the zero, so what do you think I might need to do with this function? Yep, set it equal to 0. And then zero product property, set each piece equal to 0. So I would get x equals 2/3 or x equals negative 2. And those would be my two zeros of the function. Now, this was a squared function, so it makes sense that I have two zeros. Will I always have two visible zeros?
No.
Why not?
There can be imaginary. No.
That is a possibility. I could have an imaginary zero. What else? Yeah, we could have a repeated zero. If it was like a perfect square trinomial, we could have a zero that is used twice. So a good way to check is to see that you have two, but that's not always foolproof because there are other situations that can happen. 36. F of x equals x cubed minus 25x. Any ideas what I can do to start with for this one? Take out an x. And that leaves me with x squared minus 25. What is x squared minus 25? So that would factor into what? X minus 5, x plus 5. And don't forget the x that we factored out to begin with. We've got to have that. Set this equal to 0. So I would have x equals 0, x minus 5 equals 0, x plus 5 equals 0. So I would get x equals 5, x equals negative 5, and I already had x equals 0. So I would have 3 zeros here. It was a cubic function, so that makes sense. The big thing is, if you have a cube function, you can't have 4 zeros, right? So if you get more than whatever your max value is, something's wrong. Are there any questions about those ones? Are you okay on those? You've done this before, it just looks a little different than how you've done it before. All right, state the degree and list the zeros of the polynomial function. State the State the multiplicity of each zero and whether the graph crosses the x-axis. We're not going to do that part. We're just stating the degree, the zeros, and the multiplicity. So for 39 to 42, it's going to be modified instructions. Just state the degree, zeros, and multiplicity. We're not doing everything else it says. So 40, I have f of x equals negative x cubed times x minus 2. So before I start answering all those questions, okay, I need to find out, is this in standard form? Tristan says no. That's correct. Why is it not in standard form? Yep. So it being written in this form is going to help me with zeros and with multiplicity, but it's not going to help me with the degree, okay? So the degree, I would need to get it written in standard form so I can ensure that I have it right. So this would be negative x to the fourth plus 2x cubed. So what is the degree? 4. So if you don't rewrite it, I'm not going to force you to rewrite it, but you need to make sure you multiply so that you get your degree right, because otherwise you probably would have said it was degree 3. The zeros, if I set each of those pieces equal to 0, what am I going to get my zeros are?
X equals 2, negative 2. Wait.
It's already factored here, so just set each piece equal to 0. So negative x cubed equals 0 and x minus 2 equals 0. So what are my zeros?
X equals 2.
X equals 2 and 0. Now at this point, I want to look at the multiplicity of each of these zeros. So how many times do they occur? So how many times does x equals 0 occur as a 0? 3 times, so the multiplicity is 3. How about x minus 2 being, or how about x equals 2 being a 0? How many times does that happen? 1. So when you state the multiplicity, you need to have it of each 0, so you can write it just like this and I'll know what it means, but you need to like write it across if you're going to do it like that. (42) f of x equals 7 times x minus 3 squared times x plus 5 raised to the 4th. So much like the previous one, this one is not written in standard form. So I'm going to talk about how to figure out the degree if it's not written in standard form and you don't want to multiply it, because this would be kind of miserable to multiply out. So whatever the power is here is how many times it's being used, right? And so that means that when you multiply all those together, the highest x power has to be whatever the power of this is, right? So what would the degree of this one be?
2.
Of this whole function, what's the degree?
4. Oh, 6.
6. Because I would have x squared times x to the 4th, add the exponent, so it would be degree 6. The zeros, what are my zeros of this? 3 and negative 5. What about the 7 out here?
That's
To find the zeros, I set this whole thing equal to 0. What happens with that 7? Might be a trick question, people. It just disappears, right? 0 divided by 7 is 0. It's just gone. I don't have to worry about it. So, multiplicity of x equals 3. How many times do I have a 0 of 3?
2.
2. How many times do I have a 0 of 5? Or negative 5, I mean. 4. Any questions about that? All right. The last step in this section says using only algebra, find a cubic function with the given zeros. Support by graphing. You're not doing that part. So, this will kind of lead us into the remainder of this chapter with what we'll be doing. But 54, they tell us that the zeros are negative 2, 3, and negative 5. Okay? And I want a function that is a cubic function with those given zeros. So, this is kind of like a problem where we're working backward. They gave us the function, we found the zeros, now they're giving us the zeros, we need to find the function. So to do that, and I would start out doing it this way because when we get into the next couple of sections it will make it easier. Set these each like equal to x. So x equals negative 2, x equals 3, and x equals negative 5. That's just another way to write your zeros. Then what I would do is I would move the numbers over. So you're going to end up with x plus 2 equals 0, x minus 3 equals 0, and x plus 5 equals 0. So now these pieces that I've just put parentheses around are my factors. Okay, so I will have f of x equals x plus 2 times x minus 3 times x plus 5. And then now I just multiply. So I would get x squared plus 2x minus 3x, so minus x minus 6 multiplied by x plus 5, and then I'm just going to do it again. So I would get x cubed plus 5x squared minus x squared minus 5x minus 6x minus 30. Combine like terms. X cubed plus 4x squared minus 11x minus 30. And that would be your function. Any questions on those?
Can you use the box method?
As long as you show your work and get the right answer, I don't care how you do it.
Well, I just don't know if it works for that little man.
I don't even know what the box method is. So. All right, problems 3, 5, 25, 27. Make sure I have all this right. 33, 35, 39, 41, 49, and 53. There's only a few minutes left today. You will have all of class tomorrow to do this also. Okay.